Okay. So last time we left at the one-dimension data table. We're gonna redo it. Just zoom in a little bit. So in a one-dimension data table, when you have these related formulas, when you have an input and an output, you want to test what would be the output, one or more output based on the range for the input. In this case, we pick the range as the unit sold. If my unit sold changed from 10,000 to 35,000, how much would be my revenue, my expense, and my net income? So typically the first row, always you're going to be linked to those inputs. So the first one is the unit sold. Second is total revenue, which is the one below. Expense, the one below it. And the total income is the one also down there. And then you select, you put your range, and let's even do that from scratch. We're going to put 10,000, 11,000, and you select, you can just drag 34, 35. Then what you do, select the whole range, including the first one. So when you go back to the data menu, what if analysis data table? So this can work in column format or in row format. In this case, our input is in column. And what I kind of missed last time is the column input cell. I had in mind that I should use this, even though it's the same one. But I need to point the column input cell to the B7. Yes, B7. And what Excel does, then it will take every value here and will plug it in here and take the output from down there and put them next to it, following the example of the first one you put there. So instead of you putting this value and copy paste, Excel will do that for you. So it said if I have the input cell as the unit sold, so those will be the inputs, the output for every one of these inputs. So for every unit sold, this will be revenue, expense, and net income. This actually could be either linked in this specific case, or could be simply the difference, revenue minus expense. It doesn't have to be part of the data table. But since you already have it there. So we have one input, three outputs. This is how you can see how your output changes based on a range of the input. Okay. Have another one below is based on the unit, sorry, this will be the price. It should be price. If I change the price, not the unit sold, because they're both inputs, right? I could change this or I can change that. Also, what would be the revenue model if I change the price, not the quantity? Let's say I have a cap on the quantity. I cannot produce more than, I don't know, 23,000 a day or a month. What would be, if I change the price, how will the dynamics work? How am I going to do get the break-even point? So who's going to volunteer and do this? Since you complained a lot. Oh, yeah, you guys can help her if you want. Yes.
You did the chart last time. So
yes.
Would you be doing that?
She can do it once she's done with this. So this is the price initially. 22. Let's check. 22 is
the
already
price,
linked to the price per unit. Okay, good. So on the next one.
How did you do this again? Wait. Okay. So you put
revenue. You want to link it to the revenues right there.
Revenue. Oh, revenue.
No.
No.
Actually, yeah, that's fine.
No.
Works.
No.
Same one.
Oh, but you wanna the name.
It's okay.
No.
The value.
Okay.
Enter.
Okay.
Or tab. Total expense.
No, not that expense.
Neither this one.
No.
It's the sum of both. No.
Oh, there. Down. Yeah. No.
You can call a friend or. Check the audience. Scroll down. total expense.
Oh, there.
Yes. Enter. And the net income.
And
Okay.
then you select everything, right?
Not that. One row below. Start with 22. Okay.
And then data, what if?
Now the column input is what?
It's gonna be price, so that one, right?
No.
Oh, wait, no, I put the wrong space, right? It's there.
Okay.
No?
Oh, look at that.
Oh.
Works.
Oh, was that supposed to work?
Yes. So who's gonna do the chart? Other than you. Want somebody who doesn't know how to do it. That's how you learn. Should I pick? Volunteer? Okay, if you're not looking at me, I'm gonna pick one of you. No?
Me?
Yes.
Wait, I was looking at you though.
After I said that, everybody started looking at me. So let's think about it before you start doing a chart. So we need to do an XY chart. What's the X? The X-axis is what? Is the price. So we're gonna have the price. It's okay, you can get this as a guidance. In this case, we have the units sold as the X-axis.
Mm-hmm.
So basically, if you scroll down, what we have here is the revenue changing as the price change. So the common X is the price, and then we need one Y series for the revenue, another one for the expenses.
Okay.
Right? What you can do, different ways. You can start with a blank chart, or you can pre-select the data. If you pre-select from 10 revenue and expenses, skip the net income,
Yeah, we didn't.
and do insert chart. So if you put the mouse over the middle one below here, this gives you line. We don't want line, even it looks the same. We want the XY scatter, which is the one next to the pie, to the right of the pie chart. And do this smooth
We did this
line
one last
connected.
time, right? Yeah.
Yes.
Okay.
Okay, hold on. There's something off. The expense. No, we'll cancel that. Why is the expense the all 5?
It's because the units is consistent.
Yes. Because the expense is not related to how much you sell for. It's related to the quantity.
What? Move this over.
Good. So let's simplify the y-axis and get rid of some zeros. Use 1,000 units. Go down. Display, no, you were right. Yeah.
No.
Display units. Thousands. Then you can close it. Okay, now let's fix the range a little bit. There's a lot of white space. I personally don't like that. We can, the y-axis, what's the minimum? Let's look at the chart.
200. We
go from 200 to 700, I think. Yeah, change it from 2 to 7. Minimum instead of
is
0
gonna be
200,000. 200,000. And instead of
max.
800, make 700. Okay, and the x-axis, let's do it from 10 to 30 exactly. You can either change it here.
Vertical.
Horizontal value axis, third one.
Value.
Make it from 10 to 30.
10 to 30, okay.
Yes.
What's the difference between bounds and units? The bounds is what your beginning and end is, and
Yes.
units is right?
So how are we gonna pinpoint the break even, which is the 22? We need another series. Right click, select data. Actually, edit series 1. Let's just do some cleanup. Right now we don't know which is the expense, which is the revenue, right? So this one is column, this is the X, what's the Y? It's column E. Column E is revenue. So the title, just click the first one, no, the one next to it, revenue. Okay, so this will be revenue. And the
No,
second,
that was your price, I thought.
no, this is the price, the x-axis. These are the y's. Series 2, if you edit that, so the x is still the same. The y value, actually, if you notice here, is the F column, which is that means the series name is the expense. Now we need to add another one. Just 1 point series. So this is break even. And what's the X
The X
value for
value
that
is
point?
going to be 22.
Yeah, use the top one because
Oh.
you have it. Or you said that's fine. Use 22. Okay, and the Y is what?
It's going to be 0.
No,
Oh, no, it's going to be the...
either one. They're both the same.
The same, yeah.
Okay. So make it slightly bigger. So this is 1 point series. It's not the line. Scroll up. Up, up, up. Marker. And marker options. Do built-in. If you want to change the shape, but you can make it bigger. I think that's huge.
Is it? I want to make sure we can see it.
Yeah. That's fine. And can you put the data, the X and Y of the break-even point? Can you display the values at the break-even point?
I did a data column.
Good. See? It's easy. That's it. Thank you. Was it hard?
No.
Yes. So this is how we do one variable data table. So this is how you can get different outputs for a range of input. Now, what if you want to change both? You want to get a combination, like for a range of price, for a range of quantity sold, what would be the revenue or the income? The two-dimensional data table, you can get 2 inputs and 1 output. You cannot specify more than 1 output. So let's look at an example. So between units sold and price per unit, I want to look at the expenses. Okay, let me delete these. Actually, just fix the format a little bit. So for every combination of price and units sold, I'll get one value of expense. So that's how I have one table for expense, another one for revenue, and a third one for income. Net income, there could be subtraction of these or also another data table. So the way to do it, let me just reduce the width a little bit so I can zoom in. So I have to select this range and go to data table. So here I can specify the raw input. The one on top is what? Is the price. And the column is the unit sold. But where do I specify the output? How does it know I need the expense as output? Excel's not gonna guess. We go to this cell, top left corner. Here you say equals I want to do the expense, right? Equals this. Now, when I call the data table, it knows that for every combination of these values, it's going to pull the value for total expense and put it here.
Why wouldn't you just have another input parameter?
Talk to Microsoft about that.
It just seems kind of archaic.
Most times these things actually, they still exist for backward compatibility, because this is how it was 10 years ago. And the thing with Excel, there's a lot of third-party tools built on it, of automation. So they don't want to break it. But still, they should add additional option, leave this option or add another one. So the row input cell, I guess this is the price. The column input cell is the units sold. And hit OK, gives me the numbers. To make it cosmetically look nice, let's zoom in on the table itself. You can actually change the font just to match the font color to match the background. So you don't see it when you print it, but you know it's there. And you can change the format of these to dollars without decimals. So since we said the expense are independent from the price, they're dependent on the quantity. You can see actually it goes horizontally. It increases horizontally, not diagonally. The way to visualize that, again, we can use conditional formatting. Actually, since the expense, we're going to use a negative logic. So less expense on top, more expense at the bottom. Now you can, without even looking at the number, just look at the color grading. You can see it's just strictly vertical. So it's not impacted by the price, it's strictly impacted by quantity sold, which makes sense. Now, who's going to volunteer for the total revenue other than you? I'll save you for the hard one. The only one you're not expecting. Okay. Any other volunteer?
Staring it down this time.
William?
So, in the upper left corner, I put the total revenue, which is, it's white already?
It's already white, but
Okay,
yeah, you
doesn't
can put the formula.
So there's this.
You can use that. It's fine.
Okay.
Enter.
Right, and then I go to data. What?
No.
No, not yet.
Select. Maybe you want to zoom out a little bit. Yeah, it's already there. You missed one row.
Oh, yeah. Dot. So then data. What if? Data table. Raw input. The raw input cell is unit sold.
Row. No. The row.
No. The row key is price per unit.
Price per unit.
And then column is sold. Okay. And then it's in dollars, so
okay. Put in dollar, no decimal. Yeah, the right one. Yeah, 2 clicks.
Okay.
And conditional formatting. Now this is revenue. So we're gonna have the green high.
Yeah,
right.
This is correct.
Okay. Oh, thank you. So see, it makes sense. More revenue is the higher. Okay. First, let's copy the formatting. For revenue, the higher is the positive, and it makes sense. The more you sell for higher price, the more revenue you'll do. And you see the changes diagonal. Now, net income, we can either use it the same way, or we simply can just do for each one of them. So net income is what? Revenue minus and this is relative reference, so I can simply just drag it this way, and I can verify for 2615 the same, and then I can take this, can drag it sideways. And I can apply the same formatting. I don't have to do that. I can simply just copy format and click here. You can also, with the formatting, because you want to distinguish between negative and positive for the net income, you can adjust the conditional formatting for this specific range. So you can go conditional formatting and manage the rules for this current selection. You edit the rule. Currently what it does, at percentage midpoint, you put the break line at the yellow at 50%. We can specify it as 0. Because 50% is not 0. You can have the negative end like longer or shorter than the positive end. So the middle of the whole range is not always 0. You can specify this to 0, and you can even make it specific color. So it can be strictly yellow, and the lowest could be strictly red. This is more bright green. So now you see how it changed. It shifted more to the left, the yellow part. So see, initially it was kind of like more yellowish around here. Now my computer looks a bit better. But when you specify that 0 is the yellow, you see it's kind of the red pushed a little bit to the left. So I mean that your break-even line is almost around this side. You can also specify another conditional formatting is that if it's greater than 0, it could be custom. You can make it, for example, bold, but not in red. Hold on. So the bold ones are positive. So you have two conditional formatting on the same data set. One to control the background color, one the formatting of the font. So now you know the bold ones are positive, the regular font is negative. That will kind of visually help you draw the line for each price. What would be the break-even quantity and vice versa. Let's say at 17,000, the break-even is somewhere between 25 and 30. This is why I go between positive and negative. For 26,000, I mean, logically, the break-even point is going to go less. And it's between 20 and 25, but it's mostly toward the 20. So this is how you can use conditional formatting to visualize your data set. Is it clear how we can use two data table? This is very useful to do forecasts just to see what would be the outcome of combination of inputs. Clear? Okay. So that concludes the what if analysis and solver. So we can move on to the analysis Toolpak. Actually, let me see, don't update. Okay. So for the histogram, we're going to use our art collection to see the distribution. So who doesn't know what the histogram is? Good. So we all understand how it works, but let's see how we can make sense of it. Let's look at the value. So this is the initial analysis. You look at the value. So we have 115 items. We want to see how the value is distributed, right? So the lowest value is 250. The max is 110. Average 9,000. This alone gives me something. If I think of like a normal of a curve of distribution, I have the small one is at 250 and the highest one is 100K, and this is pretty much 0. So this is my range of data. By my average is almost 1/10 of the range. So I can kind of guess that it's kind of like this. That the 100K is more of an outlier than the norm, right? And this should be reflected in the histogram once we draw it. And we have 115, and the median is 5,200. That means 5,200 even here. That means 50% of the items, the value are here. The other 50% here. That's even another confirmation that this is the values up here are only few, 1 or 2. So these are more the outliers than the norm. This is how you read this data, just at a high level. Just few values between the average and the median gives me, like, most of these R collection, the value is within this range, even though min and max, if you just look at min and max, very misleading. You need a little bit more. So the histogram will help visualize that. So what we'll do initially, if you don't want to use the histogram, I don't want to go through this, but I'm going to talk to it. Let's say you do your range from a 0 to 1,000, the 1,000 increase up to 10,000, and then you do 5,000 increase, and then 10,000 and 20,000 increase. So this is not uniform for a reason. But let's start. I want to do a regular. Just like based on the min and max, let's say we'll split. So it's almost a little bit over 100,000. Let's create bins 10,000 each. These, we'll do it again. So under data, you should see data analysis. If you don't, you need to go to File, Options, Add-ins, Excel add-ins, click Go. Make sure Analysis Toolpak is checked. Okay? You want me to do it again? Hold on, let me go with it. So File, Options, Add-ins, and these are the available add-ins built in. You don't need to download anything. Analysis Toolpak should be there. You hit OK. So you click Data Analysis, you see a list of all statistical functions available. Correlation, covariance, we're going to work on correlation. Fourier analysis, we will not. Histogram, moving average, t-test, and sampling and regression. So we're going to go over regression, histogram, and we're going to do the ANOVA. And what else? I think we'll do the t-test again. But let's start with correlation. Sorry, the histogram. So histogram, you need to specify your data set. Histogram of what data set? So for this one, we need to specify is the appraised value. And now the bin range. The bin range is this. And you need to specify if the output is going to be a new worksheet or new output range. We'll use new worksheet. And we'll hit we'll do it again with the cumulative percentage and the chart, but let's keep it simple first. Actually, the output range, I'll put it here right next to it.
That bin range you put in manually?
Yes. So I put 10,000, 20,000, and just
So
right.
we didn't use the other one, but that's different, right? The one
No, the other one is
on
different.
top,
We'll get to
Okay.
that in a minute. So this tells me first you need to verify your answer, that if you select all the frequencies, you need to get the total is 115. So that means they all got accounted for. So what this tells me, 84 out of 115, actually let's do a quick sum here. 84 out of 115 are less than 10,000. Another 22 are less than 20,000. So if you combine these two, so 106 out of 115 are less than 1. So you notice they all here. So let's try to put a percentage, cumulative percentage of that. So 84 is how much percent of 115? It's 84 divided by 115, F4 because it has to be absolute. So each one will give you how much percentage of the total is. So between the first two, that's already 92% of your population. So let's see the cumulative. How much would that be? As we progress, how would that work? You know what? Let me delete this because we'll do it again. So the first one will be equal to this. This is cumulative percentage. This is percentage. And everyone will be this plus the total of the above. What's the last value will be? 100%. So by the second value automatically goes to 92%. So this distribution of bins doesn't give me the first quadrant, the second, or the median, or the third quadrant, which statistically means along these are 115. At 25%, what would be the value of the population? 50%, which is the median, or this third quartile, which is 75%. Because you already start at 73%. So that means the first one I need to break it more. So you do histogram couple of iterations. The first one, you make the bins equally distributed. So you see how much. For this one, I still can make it equally distributed. Let's say from 1,000 to 15,000. Let's try that.
Is that less than or equal to?
Good question. Actually, I'm not sure. Probably less than equal. We'll double check. I'll tell you how. This is 10,000, right? 84. And less or equal, yes. So I rebuilt that, not using histogram, using formulas. So if these are my bins from 0, so I need to count how many less or equal than J9. How many here in the same set? Count if. I use the count if from that column. This is my data set, and the condition is not equal to actually less or equal than this value. So this will give me how many? And this will be the cumulative. This using the COUNTIF and using the same formula that will give you the cumulative. But I'll show you how to do it in histogram. So based on this, look at this percentage. Let's redistribute this. Let's create a new bin. Start with 1,000, 2,000, up to 15,000. Okay. And let's create a new histogram. Data, data analysis, histogram. Same data set, but the bin range is actually this. And the output, make it right next to it. And this time, let's add the cumulative percentage and the chart, and we'll talk to that. So remember we said less than 10,000 is 84? These are your 84. This is how they're distributed. Still, actually, vast majority of them, 40% now you have, let's say even 3,000. So the first quartile is almost close to 27. So 25% of the all items are less than 2,000, and 50% less than 5,000, and almost 75 here between these, almost around 13 or 15%. So 75 of the population out of 115 items, their price are less than 13,000, even though the max is 110. So that tells me between 80, only 20% in terms of value, in terms of items are more than 15,000. 23 out of 115. We can have this a bit longer too. But graphically, this is how we can show both columns, the frequency and the cumulative percentage. And I want to just show you how you can have a graph of two types. Each series, one is column, one is line. So these are the values. and you notice you have two y-axes. The red one, which is cumulative, has to go from the first percentage, up to 100%. Okay? So if you look horizontally, if you look at where the 25% is, should be somewhere here. That tells you where the 25% is. And the median number is about 50%. We can change the grading here to go from at like 25 lines. So we'll go right-click on the format axis of this one. Maximum is 100%, and the unit, the measure is 0.25. And the number is decimal. I don't need decimal points. 0. Now I need to add grid lines, the horizontal lines. So format axis, hold on, this one, horizontal, secondary axis values, not the values. Plot area. Chart, hold on. Close this. Design. Yes.
I think you just click on the plus sign.
Here?
Yeah.
Grid lines, there you go. You're right. And grid lines, now let me format them. And not the line, I want to format them at, oh. One second. Format grid line. These are the major grid line. Okay, these are the major grid lines. So now I can look at the first quartiles is around the 2000. The 50%, so half of the population is by this value, which is, again, I can go to this one specifically and do the data collab. Actually, I need the X for this one. Format data label. I need the data collab. So it's at 5,000. Once we finish this, we go over trend and forecast. Gonna show you actually before that, how you can get these numbers, first quartile, second, and third by formula. So you don't have to graph it to see it. So this will give you the distribution of your items. This is how you use histogram. Okay. So it seems you're out of time. So next time we're gonna continue with this. I'm not sure we're gonna be able to do the VBA because we still have a lot to cover with the data analysis. So quickly before you guys move, attendance.